Hello everyone, welcome to session. So today's session is S7-1200 encoder interface. If you want to interface encoder with your PLC, means in the S7-1200 there are the inbuilt functions available for high speed counting. So that function we can use in our systems. Okay. So there are number of pins available for the encoder interfacing. So exactly I need to check how many encoders we can connect with the PLC. I think more than 2 3 encoders we can connect. Means 4 to 5 encoder we can connect simultaneously. But we how we can connect this encoder? How we can check this value? What parameter we need to set? Okay, so everything I will be explained in this session. If you not subscribe this channel, so request to subscribe this channel, and please give the reference to this channel to your colleagues. So I need to complete 1K subscriber and also completed watch time, so I need your help. So I requesting to you, please complete it. Please help me to complete it. Okay. So about the encoder, so where encoder we can use. So there are number of application in that we can use the encoder, but mostly encoder used for the measurement. Okay, so how we can use in measurement? Okay, so today I will just give the some parameter settings and how we can get the value encoder value in the program. Okay, because I will make another video how we can calculate the encoder in in RPM. Okay, how we can get this data. Okay, how we can convert in pulse to or pulse to RPM. Okay, that everything I will be explained, but it is not possible to complete it in one video. Okay, so I will make the another video, but in this video at least I will show you how we can get the pulse encoder pulse in the program. Okay, not theoretically, obvious practically. Okay, but you can try with your hardware. Okay, so let's start. So about the encoder wiring. So 1 minute. Okay, so encoder wiring and quadrature output explanation. So this is the encoder. For example, I have Autonics E50S8 encoder. Okay, so Autonics is 5078 to S7-1200. Okay, so you maybe you already know or not, I don't know. Okay, so there are the some pin configuration. Okay, some wires. So brown is a PLC, brown is a encoder. A positive wire means it is mentioned it is mentioned that how much voltage encoder take. So uh, mostly 5 to 24 volt DC supported. Okay, so brown is 24 volt DC. Okay, 5 to 24 volt. You can also use the external power supply. Okay, 15 volt power supply also you can use, not an issue. Okay, then blue for the ground means negative. Okay, so black means out a pulse. Okay, so the out a pulse you need to connect in I0.0. Okay, so I0.0. Out B direction, need to connect PLC input I0.1. Okay, orange out Z index PLC input I0.2, and this is the earthing. Okay, sealed earthing. Okay, but in this case, if you don't want to use this out Z, you can remove this, not an issue. Okay, so two pulses is important. So if you want to check the direction, so two pulses, okay, no, not an issue. Okay, so two inputs is okay for input pulses, but you want to check, you want to use this pin for the every rotation. Means this pin output is a Z output. Z output means what happen whenever the encoder completed the one revolution, so that time this pin will give the output. Okay, so every resolution we can monitor using this pulse. Okay, but if you require you can take, otherwise not require. Okay, so PLC input I0.0 and then PLC input I0.1. So this pin we need to configure in PLC. Okay, so encoder output waveform. So quadrature output. So phase A out A means clockwise rotation. So E leads B means pulse A come first, and then B means is clockwise direction. Okay, and then B leads A, mean B comes first, and then A means anti-clockwise. Counterclockwise rotation means forward and reverse. Okay, and Z phase means it will come after one revolution. Okay, Z phase. Okay, so phase A and phase B direction detection, okay, and counting, and phase Z, okay, direction detection, okay. Some encoder has more pins. More pins means this is only A pulse, but A bar, B bar also available, okay. So that encoder you can also use, not an issue. But here A and B it's okay, okay. Now where we can use, so there are the some application in this place we can use the encoder, and right now using this encoder. Okay, so these are the common application for encoder connecting directly to the PLC. Okay, so is material cut to length. So if you want to cut the materials, okay, so in measuring wheel we can connect the encoder. Okay, so this encoder will give the position to our PLC, okay, in high speed counter. So accurate positioning for flying sailing we can use this encoder. Okay, so in seed cutting application we can use, okay, conveyor tracking and sorting. So you want to use in conveyor sorting and tracking. Okay, so in this case we can also use. What will be happening in this case, whenever the object will detected, that time encoder will set the number of pulse for the particular distance. Okay, so that data will store in the program. Okay, so remaining pulse it will be calculated, and that time whenever the means any pneumatics cylinders come. Okay, so in between measure by the encoder. Okay, product packaging and labeling. Okay, so that time also we can use the bottle sensing and remaining distance, we can calculate by the encoder. Okay, so this is the after process of the encoder value. Okay, how we can stop this labeling head, all the procedure after the uh, after the detection of the counting value. Okay, liquid flow metering. So encoder also used for the liquid flow metering. Okay, so whenever the pass the liquid, so this encoder inside the any mechanism will rotate, and that value we can check in form of pulse. But we need to convert the scale. Okay, so precise batch volume measurement and simple level positioning. We have the control motor and gearbox. Okay, so lift application or any crane application. In this application we can use easily. Okay, so this is the application, but how we can configure in program. Okay, so I will explain step by step. Okay, so this is our program. Okay, so I already used the S7-1200 PLC. Okay, so in this S7-1200 PLC, uh, we need to add, okay, and in device configuration, this is in device configuration. Okay, so here you need to click here. You can check here address of high speed counter. Okay, high speed counter. So six counter you can use, high speed six counter you can use. Okay, and this is the address of input address of the high speed counter. Okay, so this high speed counter address we will use. Okay, but how we can configure this in a program? So just right click on it. Okay, and the property. Okay, so in this property you can see here the number of encoder list. Okay, so this is the high speed counter, HSC high speed counter. Okay, so click one. So as per your wiring, you configuring in which input address. Okay, so according you can select. Okay, so HSC1. So HSC1, select HSC1. I am enabling this one. Enable. Okay, then function, which function you want to use. Okay, so for example I want to use count. Okay, so I have two phase, A and B counter. Okay, so I will select the A and B counter and counting up value. Okay, counting up value or counting down value. So if you want to increase the value, count them up, or otherwise counting D. Okay, then if you want to set the initial value or any limitation, okay, so this is the maximum limitation. Okay, any sync input, so that you can set. Okay, now only these settings is required here, no any settings is required. And now this is the input address. Okay, so this is the input address. So this is input address for HSC1. Okay, this is input address of HSC1, but you can configure another input, okay, as per your requirement. But this HSC1 is address is I0.0 and I0.1. Okay, so you can modify this address. Okay, but I request to please same address in this configuration. Okay, and now hardware output. Okay, no need to set. And this is the IO address. This is the IO address. Okay, so we will get the data in from this address. Okay, now one more thing is we need to note down one value. Which value? So HSC value. So our local HSC1, the hardware identification number is 257. Okay, so this hardware identification number we will use. Okay, now what we need to do, then we will make one block. Okay, 1 dB block. So I am adding bus 1 dB block, add a new block. Okay, this is for HSC count. Okay, HSC count dB2. Okay, and here I am adding one tag, count data. In count data, here add the HSC underscore count. Okay, so this is the data type. Now you can check the number of datas. Okay, so this blog we will use. Okay, so just I am compile this. Okay, so no any errors in the block. Okay, that good. Okay, now I am closing this block. Okay, now go to this here, and now instruction, which instruction we need to use. So our instruction is control HSC, this one. Okay, in control HSC, so here in HSC we add the hardware identification number 2750 2750. This control we mention here. Okay, HSC underscore count one dot count data. That's it only. Okay, okay, that value only we need to add. Now where we can found the data. Okay, so we can found the data. We need to use address. Which address? For HSC1. So HSC1 address, how we can get? I already told you that another time. HSC address is 1000. Okay, 1000 to 1003. So this address we will use. Okay, so directly we can use this address like a smooth. Okay, in ID 1000 or IW 1000, like that. Okay, ID 1000, input 1000 in any uh, okay, in any word, in any word, double word, we can move. Okay, so this will be our final value. So we can get this final value in this. Okay, and this final value uh, we can use in the program. We can use in the program. Okay, so using this value, if we want to convert in the mm, okay, or any degree, okay, so we can definitely convert this value. Okay, so this is up to here. I will next session I will show you how we can use this address and how we can convert in okay, convert in and another most important and interesting things is we can use this here axis control, motion control. Okay, so it is more easy. I will show you in the next session. Okay, okay. In HSC, one is the most and interesting part. Uh, Function is okay. This function, motion function. Okay, motion control function. I will explain you motion control function and which instruction we need to use and in motion control. Okay, it is more easy. It is more easy, but it is not possible to cover in this video. So I will cover in the next video. Okay, so this is our final output. So uh, we will meet. Okay, so this is the final output. So then next compile and download the program and check your value. Okay, so this is the only settings. So if you have any query, you can drop the message in the comment box, and I request to you, please do not forget to like video. Okay, and you can share this video to your colleagues. Okay, and okay, definitely we will meet in the next video. Up to that time, thank you so much for watching, and we will meet you in the next video. Okay, take care and goodbye.